Daniel Bernoulli was born in Holland into a family of genius mathematicians. It was a smart family, but they produced an atmosphere of rivalry, jealousy, and bitterness. At age 13, Daniel was sent to Basel University to study philosophy and logic. However, he really wanted to study mathematics. So while at the university, his dad taught him calculus at age 13. Daniel began to learn his father's theories of kinetic energy. His first work was published in 1724, where you begin to see his interest moving to the problem of pressure. Daniel gained fame through his work, Mathematical Exercises, and was invited to take up the chair of mathematics in St. Petersburg. Daniel Bernoulli is best known for his studies of fluids and their properties. He lived a life full of accomplishments, but today we're only going to talk about one of them, his discovery of the Bernoulli principle. Bernoulli's principle states that as the velocity of a fluid increases, the pressure exerted by that fluid decreases. So pressure and velocity in a moving fluid are inversely proportional. For example, if the pressure is high, the velocity is low, but if the pressure is low, the velocity is high. Bernoulli's principle explains many things in our everyday lives. Flight is explained by Bernoulli's principle. Lower pressure is caused by the increased speed of the air over the wing. Since the pressure is higher beneath the wing is pushed upwards, causing the airplane to fly. The velocity of the water increased, creating a lower pressure on this side of the ball. So this side of the ball had the higher pressure, which pushed the ball into the stream of water. Have you ever been in the shower and had the curtain keep clinging to your leg? Because it's really annoying. Well, the water rushing from the shower head creates an area of low pressure inside the tub. While on the outside of the curtain, there's an area of high pressure which pushes the curtain in and clings towards your leg.
When we talk about pitchers and we're looking at pitchers to be prospective student athletes here at Ohio State, one thing that's really critical for us is their ability to throw a second pitch. And that second pitch in most cases is a curveball. So it's very important that our pitchers have the ability to spin a good break and ball, get some depth on that break and ball to keep the hitters off balance.
Coach, how much do you want your players thinking about aerodynamics when they throw a curveball?
It's a good question, and I think the answer to that question is I want them not to be thinking about it, but I want them to understand it.
So are you ever thinking about aerodynamics when you're throwing the pitch?
No, never. I'm just thinking about trying to get it across home plate and trying to make the batter swing and miss.
So when you run your hand across the baseball, you can feel the individual seams on it. The air that you're throwing the ball through is the exact same way. It feels those seams. So as you're putting a spin on the ball, those seams and the ball itself, to an extent, is dragging air along with it as it spins. And what that's doing is that's moving, it's slowing down the air on the top of the ball as it's moving into the wind, spinning up on the bottom, and it's creating a pressure difference.
From the Bernoulli equation, there's a relationship between pressure and speed. And so that Bernoulli equation tells us the lower speed air on the top is going to have higher pressure, and the higher speed flow on the bottom is going to have lower pressure. You got high pressure and low pressure that causes the ball to drop, which makes that curveball break. And another word for that is the Magnus effect. German engineer back in the 1800s first discovered this, where you've got a spinning ball or a spinning cylinder having that high pressure on top and the low pressure on bottom. That's the basics of a curveball from an aerodynamic standpoint. Not that I could ever throw one.
You hold the curveball like this with your middle finger on the waist. You really put pressure on that. And you throw it just like a fastball, but at the last second you want to flip your wrist over and really get some flick so the ball's spinning forward and then dropping off at the last second. So it's just flicking your wrist.
So you actually create the spin, but then aerodynamics takes over and does the rest of it.
Yeah, I guess so. I guess it does work like that. I never really thought about it.
So basically, when the pitcher throws the ball has to move through the air, kind of pushing the air out of its way. So the air at the top of the ball has a lower speed, so a higher pressure, and the air at the bottom of the ball has a faster speed, so a lower pressure, causing the ball to spin and then... I hope this video helped you understand Bernoulli's principle. Go Science and Roll Tide!